Welcome to physics, distance, speed, and time. So what I need for you is to make sure that you are getting down the additional notes that I'm going to be adding to your booklet. Please make sure that you're recording it, as it will be important for you while you're completing your assignments. So to find the average speed of a car in units of any measure, meters per second, kilometers per hour, miles per hour, etc., this is supposed to say divided, the total distance covered by the entire taken for the trip. We use a small v to represent speed, so that's v. This means that the average speed, v with AVE tacked onto it, equals the change in distance divided by the change in time. Or it gives us here a formula that we can use. So we're just going to add a little bit of information so that way you got a better understanding of what it means here. So we've got small v to represent speed. This is what this is. So we're just going to add to it. Let's make that look like the word speed. This AVE at the bottom here, that represents average. So here we're talking about average speed. Here we have delta D and delta T. Delta means change. We're just going to write it over here on the side. So here delta D means change in distance and delta T means change in time. You can pause here just to make sure that everyone's getting the information down. All right, moving on. So where delta D means the change in distance, and I just talked about that, or delta D also equals D2 minus D1, the final distance minus the initial distance. And delta T means the change in time, or the final time minus the initial time. So keep in mind that when we're talking about when you see D2, it always means final distance. D1 always means initial distance. T2 means final time. And T1 means initial time. When you subtract either of those, that's the change. So average speeds are found usually for a long trip or over a long period of time. Instantaneous speed. So if we wanted to find the speed of an object at a particular instant, we would be determining the instantaneous speed. So, for example, when Mr. Dearland was driving back to Winnipeg from Fort Frances last weekend, at the moment that he drove past an RCMP, he was traveling 120 kilometers per hour, while the average speed for the entire trip was only 95 kilometers an hour. So, at a particular moment in time, we would find out the instantaneous speed. And here, that particular moment in time was indicated by the passing of an RCMP officer. It could be a particular timestamp. So, almost just like when you're looking at a video and you want to, you know where to start it from a certain point, you would go to that certain timestamp and then start from there. So, it's kind of like that. You're just looking at it from particular points in time in order to find out what that speed was at that time. Constant speed is a term that refers to the motion of an object that is not changing speed at all. So for this to happen, the instantaneous speed must remain the same for a period of time. A good example of this is cruise control on a vehicle. That is a device used to maintain a constant speed. All right, so we're going to flip to the next side. Make this bigger so you can see. Not to worry about the picture on the side. So we're going to take a look at our sample problems. Make sure that you're adding information as we go along. Now, most of these sample problems are already laid out for you, but I'm going to explain them so you know how they are set up. So sample problem number 1. So we got Eco skates to school a total distance of 4.5 kilometers. She has to slow down twice to cross busy streets, but overall, the journey takes her about 0.62 hours. What is Eco's average speed during the trip? So the change in distance is 4.5 kilometers because we don't have to figure out initial and final distance. And the change in time, 0.62 hours, we don't have to find the initial and the final time. It's already laid out for us. So in order for us to find the average speed, we're going to take delta D and divide it by delta T. And you just make sure that you fill in the appropriate information with the units onto your problem. So when you are writing down your information when it comes to assignment work, you should always start with the formula, just like we do in mathematics. Always start with the formula so that way I understand that you know the appropriate formula that needs to be used. And then you're going to plug in the numbers in the appropriate areas. So for the change in distance, I know it's 4.5 kilometers, so I know it has to sit above the bar. And then the change in time, I know it's 0.62 hours, so I know it has to sit below the bar. And this bar indicates that it's going to be division, so all I'm going to do is divide 4.5 divided by 0.62. You can punch that into your calculator to find out what it is, and we get 7.3. And we need to add the units. Here it's kilometers per hour. We indicate that kilometers per hour. So Eco's average skating speed is 7.3 kilometers per hour. We're going to take a look at sample 2. So imagine that you're riding on the Caribou Dayliner, it's a train, in the dome car, of course, and you see a sign that reads 120 kilometers. You decide, after seeing several such signs, that you're going to measure the elapsed time between the next two signs. Those two signs are 10 kilometers apart. You read the elapsed time as 390.6 seconds. So determine the speed of the train in kilometers per hour during the elapsed time. So delta D equals 10 kilometers because that's the distance between the two signs. So here we've got delta T equals 390.6 seconds, and we've got all of this information that's here. So I'm going to walk you through it, and that means I'm going to write it down here in the space. So it's going to look eventually the same, but I want you to know how to accomplish it. So we know that delta T equals 390.6 seconds. But the thing is, the question here is asking for us to figure it out in kilometers per hour. And we have to change the seconds into hours. So we know that there are 60 seconds in 1 minute. So we're going to multiply it by 1 minute over 60 seconds. And because we're dealing with fractions here, we're going to put this 390.6 seconds over 1. And because we are going from minutes into hours, we're going to multiply by 1 hour equals 60 minutes. So this is how our things are going to work. So we've got seconds here, and we've got seconds here. So we're just going to cancel out those units because we know that if we take something and divide it by something, it's going to equal 1. So if we take a second and we divide it by a second, it's just going to equal 1. It's not going to make any change to our calculation. And we also know that this minute here and this minute here will also cancel each other out. So we're just going to cancel that minute out and that minute out. So I'm just going to rewrite it just underneath so you can see it without those extraneous little units. Oh, let's use a color you can see. The only unit I'm leaving on there is the hour, because that's what we want to change it into. So when you're dealing with fractions and you're multiplying them, you're going to multiply straight across. So 390.6 times 1 times 1 is still going to be 390.6. This time I'm going to put the hour there. We're going to multiply straight across. 1 times 60 times 60. And we get 3,600. Now we want to be able to solve this, so we take 390.6 and divide by 3,600. And you're going to get the answer of 0.1085 hours. So if you take a look, we're going to go move back here. That's where we got this particular number from. So we did all the work just like they did. It's just that I walked you through it so that way you understood how it happened, where they got the number from. So now we know our delta D. We now know our delta T in hours. And so that means that we're going to divide the two. So we take 10 divided by 0.1085, and we get 92 kilometers per hour, thereabouts. All right, we're going to continue on. We got some more problems. And yeah, there's a lot of examples in this particular section, and it's only so that way you've got a lot of examples to look back upon in case you're having troubles. First thing that we're going to do is we're going to put some information at the very top of our page just so that we've got it. We're going to put our formula that we're working with. So we've got average speed equals delta D over delta T. But we may want to change things around in this formula in order to figure them out. So, for instance, what if we want to figure out time, the change in time? We want to know what that is. So that means delta T equals delta D divided by the average speed. But what if we want to figure out for the change in distance? So delta D equals the average speed times by delta T. So it's important that you have all of these up at the top, and you can do that on your next couple of pages. That way you've got a reminder of what these are. So this one finds average speed. This one finds change in time. And this one finds change in distance using the information that's given. All right, let's look at our first sample problem on this page. So Kira is trying to predict the time required to ride her bike to the nearby beach. She knows that the distance is 45 kilometers. And from other trips that she can usually average about 20 kilometers an hour, including slowing down for the climbing hills. So predict how long the trip will take. We're identifying the change in distance, which is 45 kilometers. We have that here. We only know the average speed that she can do, which is 20 kilometers per hour. We want to know how long it's going to take. We want to know the time. So we're going to take our formula and we've rearranged it to find out time. So delta T equals delta D divided by the average speed. And we did that way up here. Now all you do is plug in your information into the appropriate spots. Delta D, we know is 45 kilometers. So it's above the bar. Average speed, we know is 20 kilometers per hour. So it's below the bar. And it also looks like this, just so that you understand how it can also look. So we have our 45 kilometers. And here it says it's dividing by 20 kilometers per hour. So I'm just going to show how that actually looks. I'm going to do it the long way. So divide by 20 kilometers per hour. I'm just going to put I'll do that next. All right. So when we're dealing with fractions, and I don't know if you still remember this from before, that when you're dealing with fractions and it's dividing, you always change the divide to times and then you flip the second fraction. You flip it upside down. So that's actually what we're going to do next. I just need to move over here so we've got some room. Make sure you're getting this down as your example. So we have 45 kilometers, and I'm going to put it over 1. We're changing the divide to times, and then I'm going to flip that second fraction. So now it's h. I'm going to put 1h over 20 kilometers. And if you remember before, because we've got this kilometer and this kilometer, this is like saying kilometers divided by kilometers. We don't need them. They cancel each other out. So we're just going to cross that one off and cross that off. Just the units. We're not crossing off the numbers. We're going to multiply straight across, so we're going to take 45 times by 1. And it's still 45, but we're going to stick the h there, the hour. And then we're going to take 1 times 20, which is still 20. So now you do your division. So 45 divided by 20, and you're going to get 2.3 hours. That's how it works, and I wanted you to be aware of that. And there we got our answer, 2.3 hours. Now, it gives you another option, but I don't want to confuse you anymore, so you're going to just kind of cross that out. So here, we're just going to show a simple way of how we figured out the answer in sample problem 3, especially when we're talking about division in kilometers of hours divided by kilometers in hours. So here on the side, we've got kilometers divided by kilometers per hour. And here we're just going to be showing the inverse. So for example, just like we did before in example 3, we have kilometers divided by kilometers per hour. And because we're dealing with a fraction here, we consider this a fraction. So we're going to use the rules when it comes to fractions and division. So this changes the times and this flips upside down. And now, just like we did before, this is like saying kilometers divided by kilometers, so they cancel each other out. So the only thing we have left is hours. So our answer would be whatever it is with hours. It's just a simpler way to remind you how we're using our math skills when we're figuring out specific units in physics. Okay. So we're moving on to sample 4. So Jana has a summer job helping with bison research, and she notes that they graze, move, and eat grass at an average speed of about 110 kilometers an hour. For about 7 hours per day. What distance in kilometers will the herd travel in 2 weeks or 14 days? So here we know the average speed. It's been given to us, 110 kilometers per hour. Here's the time. So here we're figuring out the time right here. So we've got 7 hours per day. That's what's given to us here. Times by 14 days. See these days here? They cancel each other out. That's like saying day divided by day. We don't need those. So if you take 7 hours times by 14, we'll find out how many hours in total. So we get 98 hours. So these are the two numbers that we're going to be working with. So we want to find out the distance in kilometers. So we're going to use our formula that we figured up here at the top when we're figuring out the distance. We're going to take the average speed and we're going to multiply by the change in time. And we have that already here. So all we do is plug in our numbers. 110 meters per hour times by 98 hours. So we're just going to take this information and we're just going to figure it out over here on the side. Again, we're just walking it through. And that's what I want you to do too. Make sure that you're following along with me and getting the information down. Again, we're getting our formula that we're working with. And we're going to fill in our information. And if we take a look here, we've got an hour here and we have an hour here. This is like saying hour divided by hour. We don't need those. So we're just going to cancel them out. So all we have to do is multiply straight across. I'm just going to rewrite it so it looks a little neater. So we have 110 meters times by 98. And now all we do is figure it out. So 110 times 98, we get 10,780 meters. But we want to know how much it is in kilometers. So that means we have to divide by 1,000 meters per kilometer, because there are 1,000 meters in 1 kilometer. So we take 10,780 meters, divide by 1,000. Remember, this one and this one, they're going to cancel each other out. So we don't need those two. So once we figured out our answer, it's about 10.7, I think it's 7 repeating. So we're just going to round it up to the nearest kilometer, and we're going to say 11 kilometers. So if you take a look here at the sample itself, it gives us our answer of 11 kilometers. Here it gives you another alternative, but we're just going to cross that out. So it says, according to Jana's observations, after 2 weeks, the bison will have covered a distance of 11 kilometers. All right. We're going to flip the next page here. And it's understanding concepts. So you are going to be determining the answers for each of the ones that are circled. And these you can definitely do. You can use the samples that we have as your examples to help you out. And you can also ask the adults in the classroom in order to do that too. I want you to be incredibly neat while you're doing this, because it's going to require you to organize your work. So number 1, it asks, how is average speed different from instantaneous speed? Well, look at the front of your information. You should be able to explain that to me. And B, when are they the same? It tells you. You should be able to explain that to me. Number 2, a car and a truck travel along the same highway with the car moving faster than the truck. Now, you're going to be answering this based upon your own knowledge just about travel when you're in a vehicle. So how do their distances traveled compare after the same length of time? So think about it. If you're traveling on a highway and you're going the same length of time as the person in the car, but the thing is they're traveling faster, what's the distance going to be like for you compared to them? B, how do their times compare after traveling the same distance? So let's say you travel the same distance, but what are your times going to be compared from you to them? Number 3, holidays might mean a multi-day trip to be taken by foot, boat, train, or automobile. So the Trans-Canada Trail, for example, has become a popular hiking and cycling vacation route. So you're going to answer all 3 of these here, A, B, C, D. And pay attention to what it's asking, paying attention to the information that's given. We've got 6 hours here. We've got 31 kilometers. And it says, what's their average speed for the day? So if it's asking for average speed, then that means you're going to be using the formula to determine average speed. Same thing with B, it's asking for average speed. For D, it's asking for distance, so you're going to use the formula to figure out distance. And then here for D, it's asking what length of time, so you're going to use the formula to determine time. Next one's 4. It says the cruise control of a car is set at 90 kilometers per hour. What distance is traveled by a car during 2.5 hours? It's asking for what is distance. So you're going to use your your distance formula. Number 6, use the conversion factor in question 5 to convert. So I'm actually going to have you just hold off on number 6 for right now. If you want to make an attempt on it, by all means, give it a shot. You can use the examples that were in sample 3 to help you. Maybe you can figure it out. But if you're still not too sure, just hold off and we'll work on that together. And number 7, you can definitely do A, B, and C. So remember that the keywords that you're looking for. Here it's asking for average speed. B is asking what length of time. And C, it's asking how far did it travel. All right. I am going to be very particular. You need to find yourself a piece of loose leaf. And I'm just going to pull up an extra screen here. I'm just going to change it so that way it will look like loose leaf. Just give me a second. So you're going to add a title to the top. Make it nice and neat. So understanding concepts. Neater than mine. And this is for the section on distance, speed, and time. And I'm just going to write it underneath. Distance, speed, and time. You're going to underline your title. Wow. You're going to have today's date. And then you can start your work. I'm going to be really picky about you making sure that everything is nice and neat and organized, because that way when it comes to test time or anything like that, you know what this particular assignment refers to. So that way you're not trying to scramble and try to figure out what the heck it is that you're doing. I do kind of suggest that you put the formulas that you are working with off to the side so that way you can remember them, just as a helpful reminder. So if you want to pull them off to the margin or off to the left side or the right side, that's up to you. I'm just going to put them on the right side here. So these are the formulas that we're working with. We're working with average speed, we're working with time, and we're working with distance. So that way I can refer to these as I'm doing my assignment. Just a helpful hint. All right. Remember that there are people around in the room to help you. You can always refer back to your samples as well. Please try your best. Make sure that you're working and using your time appropriately. We will also be going through this as fast as we possibly can, and I know that you guys can do this. If you happen to be working at home and you're not too sure what you're doing, please, you can always send me a message through Teams. You can always send me an email, or you can always send me a text, and I'll help you out as best as I can. I'll see you soon.